We're part of a ecosystem of so many individuals, companies, agencies, and researchers at the University of Oregon and OSU.
And we have engineers, we have architects, we have fabricators who believe in mass timber.
We're all trying to get to this mass timber adoption threshold, and we're all pushing for it to happen, and it doesn't feel adversarial at all. I think it feels super collaborative.
It's like a party where everybody gets to dance with each other. But
it's like a team. The more you play together, the better you get. And we've been able to refine how we do things over multiple projects. And that didn't just happen overnight. It happened because we've been working on these systems for 10 plus years.
It's this constant tinkering and, learning from one project to another. That's the innovation.
This isn't just a project, it's a vision.
The art and design building has been a long time coming. We had the vision that mass timber could work, but it had to work financially, right? We get a certain amount of budget from the state and there isn't any more money. And so if we can't make it work, then mass timber wasn't going to be it. So we began touring some of the other projects around town to see how efficient we could become with the timber and what schedule efficiencies we were going to get so we can have the savings on the back end.
We really worked on optimizing how far can we span with a 3-ply panel, which is the thinnest CLT panel, and then using that sort of module for everything.
We start to understand, okay, here's the grid, here's the layout, this is where we're gonna put all the wood structures.
The basic DNA of how that structure works, it's always the same. It's just rotated.
And that was really imperative to bringing this into budget, but also creating the right building for the site.
And at the end of the day, we were super pleased to be able to make that happen, and really because of the creativity of the architecture and the construction team.
It's also gone incredibly quickly in terms of its construction. So we were able to do like 27,000 square feet of structure of the timber of the first floor in 10 working days.
The schedule benefits of that are significant. It's going to be an incredible building. I think the best art and design building on the West Coast.
Let's create space that we can't replicate anywhere else on our campus.
At Oregon State, they're doing this one new building that needs to bring in, the supercomputers. They have research labs in chemistry, oceanography. There's a virtual reality lab. There are classrooms for undergrads.
Innovation's in the word. We've got to move forward and we've got to try something unique here. Can you do wood in a wet lab?
We went on a tour of comparable facilities in other institutions here on the West Coast. We went as far away as Texas. They all have collaborative innovation centers, and guess what? They're all steel and concrete. And OSU said, yeah, this is all awesome, but we want to do this in mass timber. And we said yes.
Can we do that? Yes, we can. Let's just give it a try.
The greatest factor that had to be overcome in the mass timber design was the stringent vibration requirements.
KPFF structural engineers really came back to us and they proved to us that they could maintain the vibration criteria out of mass timber.
This arrangement of framing elements, this geometry, the bay spacing, all these components were engineered for lab performance and organization, immediately followed by vibration control.
Even though everybody was excited about wood, we had to demonstrate that a wood building will cost in line with either building in concrete or steel.
So here I am at Cut My Timber, and this is the shop, and this is the machinery where we fabricated all of the MPP beams and columns that make up the primary structure of the HCIC project in Corvallis.
People think that mass timber is so much more expensive, and in this case, it really wasn't.
It's going to feel like a real thing. It smells, like you're somewhere rather than nowhere.
Yeah, it evokes emotion and warmth, and it's a place you want to be.
It's inviting people to experience and stay and learn, and it's obtainable, and it's for everyone.
As we were working in Oregon State, we won this competition in Barcelona. The original proposal was in concrete, but because of the Oregon State project, because that was a little ahead of time, we went back to the Barcelona client and we said, look guys, we actually think that your building we could do in wood. It's also a research building, has these like complicated labs. So we ended up redesigning the structure for the Barcelona building based on the structure we have at Oregon State.
Timber Labs, 200,000 square foot Indy Hall, which would be probably the most sophisticated, CLT manufacturing facility in the United States, just an hour and a half from here, and it's an all timber building.
But in my wildest dreams, I could never imagine that we'd have the opportunity to design the space to house the next generation of CLT presses, to build the next generation of CLT buildings across the Northwest and hopefully around the world, sourced from some of the most beautiful and productive forests we have on the planet.